Oh, so let's solve this question. The question states that consider the following two languages over the alphabet A comma B. So these two languages have been provided to us and we have to consider these languages and which one of the following statements is basically correct, right? So among these statements which are correct, right? So it is basically asking for us only one single option. So it is a MCQ type question. Okay. Now let's solve for that. Basically it's saying that both L1 and L2 are regular languages. L1 is regular language and L2 is not a regular language. L1 is not a regular language, L2 is a regular language. L1 and L2, neither of them is a regular language, right? So we have to consider these two languages. They are shown to us in a set theory format, so we have to consider them, right? So a regular language can be is expressible in terms of regular expression. So if you can formulate a regular expression that can show you the whole pattern for this, that is a proof that yes, it is a regular language. If you're not able to show, that could also be a proof that your regular language expressing skills is not very good, right? So there is always this aspect when it comes to mathematics, right? Sometimes you don't your own expertise may be the thing that may be lacking. Obviously that is something which only comes with practice, and that is why we must practice when it comes to developing whatever is required, right? And notable in this terms, theory of commutation, right? So let's try that. Let me try. Let's okay. So it is basically stating to us that alpha is basically A comma B whole positive closure. So in a format terms, what does this thing means? It means that it can take strings like this, A, B, A, and so on and so forth. So basically it doesn't, because it is a positive closure, so it will not have the empty string, right? This epsilon will not be part of your answer, your set. But other than that, all possible combinations of A comma B is going to be part of that of alpha. Likewise beta is also of showing same pattern. Now the string that is made from alpha, beta, alpha by itself, you would have to store alpha and then reproduce it, right? You would have to store alpha and then reproduce it. So that kind of behavior is not generally regular, given the possibility that you do not have some way to simplify this string. The patterns don't simplify themselves, right? In this situation, the sample by itself, the beta, cannot absorb any part of alpha because it is not the reverse of alpha that is present over here. If the reverse would have been present, then beta could have eaten everything and would have stated that it could be some kind this kind of string, basically this kind of string, if it would have been reverse possible. Why? If you may say, if it is reverse, suppose that alpha is equals to A B B, reverse of alpha is going to give us B B A, right? And if you notice, the first term is going to come at the last, right? And if I were to be starting with B, then it will end with B, right? So only these two kinds of patterns would be possible if it were reverse were to be allowed, and that is what I am talking about, that the middle term basically eating up parts of alpha and then simplifying it, because this expression is basically a regular expression, right? Both of those are regular expressions, and both of those can be included selectively by basically using the plus operator, right? The plus operator, the inclusive OR operator that is present in your regular expressions, like this, right? Pretty simple. And so that kind of thing cannot be done because the reverse of alpha is not present, so beta cannot simplify it. Any expansion of beta does not eat up any part of alpha, so it cannot be simplified. Hence alpha is not really a regular expression, not regular, right? Now your L2, it is actually this kind of string. It is not even context free, it has to be context sensitive. You need a tuning machine for this, right? A push down automaton would also not be able to do it, much less what could a finite automaton possibly do, right? L2, let's consider. L2 basically means that alpha, beta, alpha, right? Alpha can only take a single kind of alphabet, and that's star. What does this kind of expression means? It means that your total possible set of strings which alpha can take is basically equal to A, and then so on and so forth. This kind of pattern, right? So this is your alpha, and beta is basically anything, right? If that is the kind of pattern which is present, so it basically, this whole thing can be reduced down to this thing, only the first part, not the second part, this thing. Why? Because whatever be alpha, if alpha has n number of terms over here, then alpha is going to have n number of terms over here, and beta can have anything, b, a, something, right? So all of these n minus 1 alphas, n minus 1 alpha can become part of your beta, right? And that kind of beta is going to be absorbing up everything, and it is basically going to become a string that starts and ends with a, and in the middle there could be anything, right? And that is because that kind of string is possible, that kind of simplification of this kind of pattern is possible. That is why L2 is basically equivalent to a regular language, because every single set of possibility that it will produce can be expressible in terms of normal regular expression, and that is why you can say that this is a regular language. What is the regular expression for this, so that you have very clear? I am writing it again over here, right? This is your regular language, regular expression for that language. Very simple, very clear. So which one of the options basically state this? L1 is not regular and L2 is regular. So the correct answer for this is C. A pretty straightforward question. I do think that you must have been able to solve it by yourself, and this video only provides validation for what you have already solved. Other than that, have a very good day. I will see you in the next video.